Today, we're going to crack open the hardware that's really the engine behind the modern AI factory. We're talking about the NVIDIA ConnectX-8. But look, this is not just another network card. It's something they're calling a SuperNIC, and we are going to deconstruct exactly what that means and why it's so critical for AI computing. Okay, so first things first, to really get why the ConnectX-8 even exists, you have to understand the problem it's built to solve. Modern AI models are just gigantic. They run across thousands of GPUs all at once. It's kind of like trying to have one single coherent conversation with 1,000 people simultaneously. If those connections are even a little bit slow or laggy, the whole thing just grinds to a halt. And that's the massive bottleneck that traditional networking hardware is hitting right now. And, it's not even a one-size-fits-all problem. AI training and AI inference have totally different demands on a network. On one hand, you've got training. These are huge, synchronized jobs that can run for weeks. For them, even a tiny, super rare delay, what we call tail latency, can slow the entire process down. But then, on the other hand, you have inference. That's all about handling millions of smaller, on-demand requests, where raw speed and just sheer efficiency is everything. So a super network has to be a master of both of these worlds. So the solution, it's not just a faster network card. It's a completely new class of device. NVIDIA is calling it the SuperNIC, and it's been designed from the ground up to be more like a co-processor for the entire data center, built specifically for these unique AI workloads. So let's actually break that down. What is a SuperNIC? Well, it's not just a dumb pipe shoveling data back and forth. It has its own processors, its own intelligence built right in. It uses some really advanced technologies to become an active participant in the computing, not just some passive cable connecting the GPU to the network. All right, now for the really fun part. Let's take a tour inside the ConnectX-8 and actually look at the core components that make all this incredible performance possible. We're going to go block by block and see how this thing is put together. Our first stop on the tour is how this thing connects to the rest of the system, and that's the integrated PCIe Switch. Think of this as the main superhighway that links the SuperNIC to the host system and, most importantly, to the GPU. And this one is special. This is so critical because it's the very first commercial deployment of PCIe Gen 6. That's the kind of massive bandwidth you need for 800 gigabit networking. Now, by handling all that traffic itself, it frees up NVLink, that's NVIDIA's super fast dedicated link between GPUs, to be used only for GPU to GPU chatter. And that is exactly what you want. It also acts like a traffic cop, managing quality of service to make sure data is flowing perfectly between the network, the GPU, the CPU, and storage.
So, we've got the SuperNIC connected to the GPU. Now, how does it talk to the rest of the network? Well, get this. The ConnectX-8 isn't just a network endpoint. It has a powerful Spectrum-X Ethernet switch built right onto the chip. This is a huge deal when you're trying to build these massive AI clusters.
By putting a switch right on the card, the SuperNIC basically becomes a smart extension of the main data center network. It can handle really complex stuff like load balancing and congestion control right there at the source before the traffic even gets out onto the main network. This just makes the entire network smarter and lets the application just, do its job without worrying about all that underlying complexity. Okay, we have now arrived at the engine room. This is the core technology that makes the mind-bending speed of the SuperNIC possible, the 800 gigabit RDMA engine. And RDMA stands for Remote Direct Memory Access. And here's why RDMA is an absolute game changer for AI. It lets one computer's GPU write data directly into another computer's GPU memory, completely bypassing the CPUs on both sides. I mean, this just slashes latency and frees up the CPU to do other things. And the ConnectX-8's engine takes it a step further, adding programmable congestion control right on top, making sure that fire hose of data flows smoothly and reliably at full speed. So we've seen the massive data pipes. But what makes the ConnectX-8 a SuperNIC is the on-chip intelligence that's managing everything. So let's take a look at the programmable brains of this operation. The ConnectX-8 has two main processors. And honestly, this slide's analogy is perfect. You can think of the PSA processor as the security guard and traffic cop, checking every single packet that comes through. And then you've got the DPA processor, which is the network efficiency guru, and it's constantly looking at the network's health and making tiny adjustments on the fly. The PSA's job is absolutely mission critical.
I mean, it's handling things like encrypting all the data on the fly at 800 gigabits per second. It's enforcing security boundaries so different AI jobs can run side by side without seeing each other's data. And it's constantly gathering health data, telemetry, from the network to make smarter routing decisions. Now for the DPA. This thing is a powerful 16-core RISC-V processor, and its entire reason for being is optimization. So when the hardware pipeline senses the very beginning of a traffic jam, it shoots an event over to the DPA. The DPA then runs its algorithms to maybe reroute traffic or adjust data rates. And here is the key insight. It stops a slowdown before it can actually impact the AI job. It is proactive intelligence, not just reactive problem solving. This is a fundamental shift. Of course, all this amazing hardware is pretty useless if applications can't actually talk to it. So now, let's see how the full software stack brings all these capabilities to life. This slide shows the command chain perfectly. At the very top, you've got an AI application that's using a library like NCCL. That's how the GPUs all talk to each other. That library then talks to NVIDIA's DOCA software interface. DOCA translates those high-level requests into these low-level commands called RDMA verbs, which the ConnectX-8 hardware just executes directly. It's this clean, layered stack that makes all that hardware power actually accessible. Okay, we've toured the architecture, from the PCIe Switch all the way to the programmable processors. So now for the most important question of all. What is the payoff? What's the bottom line? Let's look at the real-world performance gains this whole thing delivers. And the results are just dramatic. Take a look at this chart. When you're running a big language model training job alongside other network traffic, a standard NIC just gets bogged down. It takes about 23 seconds per step. But with the Spectrum X platform and the ConnectX-8, that time plummets to just 13.9 seconds. And it stays there, rock solid, even when the network is busy. That's a nearly 60% reduction in training time. That's a massive win. And the wins just keep on coming. Thanks to that intelligent integrated load balancing we were talking about, you get 1.6 times higher effective bandwidth. That means more of the network's theoretical top speed is actually being used by the AI job, not wasted fighting traffic jams. It's about efficiency, not just raw speed. Okay, this one is just wild. Those on-chip processors allow for 1,000 times faster collection of network health data. I mean, imagine going from a blurry snapshot of your network once a day to a high-definition, real-time video feed of its health. That is the level of visibility we're talking about, letting operators see and fix problems before they can ever affect a job. And finally, for a really critical AI training operation called all-reduce, which is basically where all the GPUs sync up their results, the performance is 2.2 times higher. And this is a direct result of the SuperNIC's ability to shield that important AI job from other noisy traffic on the network, keeping its performance consistent and totally predictable. You know, I think this quote from the source material really just sums it all up perfectly. The way we think about computing has fundamentally changed. It's not about a single server anymore. The entire data center is the computer. And in this new world, the ConnectX SuperNIC isn't just another component. It's the essential link that turns thousands of individual GPUs into one massive, cohesive AI supercomputer. And that really brings us to our final thought. The ConnectX-8 is an incredible piece of engineering, designed for the absolutely massive AI models of today. But as these models just keep growing exponentially, it leaves us with a pretty fascinating question to ponder. What on earth will the network for tomorrow's AI demand? Thanks for joining me.